Hi, everyone. Thank you for joining. We'll wait a couple of minutes for everyone to join in, and then we'll get started. All right. Well, thank you everyone for joining today on our webinar for how to harness geospatial technology for good. I'm Maya Bitone, Senior Manager of B2B and Partner Marketing at Foursquare, and I'm very excited to be joined by our amazing presenter today, Foursquare Senior Staff Engineer, Nick Rabinowitz. For those of you who aren't familiar with Foursquare, we are the leading geospatial technology platform. Powered by deep machine learning and privacy-first insights, our tech helps businesses make smarter decisions and build more engaging customer experiences. Now for the agenda for today's session, Nick will cover off on what is Foursquare for Good, why geospatial analysis. He'll then go through a demo of how to use geospatial analysis to answer a question for fictional Atlanta Food Bank. And then we'll have some time for Q&A. So please feel free to submit your questions throughout the presentation. There's actually a section in the GoToWebinar platform for questions that you can submit, and we'll get to your questions at the end of the session. Now I'll pass it off to our awesome presenter, Nick. Nick, take it away.
Thanks, Maya. Hi, I'm Nick Rabinowitz. Just kind of briefly introducing myself. I'm a senior staff engineer at Foursquare, and I've been here for maybe 3 years. Before that, I had a career as a software engineer, but also a career working in the nonprofit space. So I spent about 10 years working for organizations like the Women's Funding Network and Care USA and Oxfam America. And so just to kind of give context to this talk, I really care deeply about the intersection of technology and its uses for social good. So this talk is sort of sponsored by Foursquare for Good. Foursquare for Good is our social impact initiative. It helps us to contribute to social good by finding ways to partner with nonprofit organizations, helping them to use our data, use our geospatial products in ways that can really contribute to their mission. We try to equip organizations with what they need to either respond to crises or to work on projects that positively impact their target communities. There are lots of ways that we could potentially partner together. So I just want to shout out that if you're interested in this, please get in touch. We have this website, the URL shown on the screen, location.foursquare.com/company/Foursquare for Good. You can also reach us at forgood@foursquare.com. And we'd love to talk to you about ways that we can partner if you are involved in a nonprofit organization or a social good project. So I wanted to take today to start by talking about why you'd want to do geospatial analysis at all. Most of the nonprofit organizations I worked with in the past didn't really see this as a big part of their work. And now that it's a big part of my work, I would love to have more people take advantage of it. And so I thought it would be useful to kind of go over what kinds of benefits geospatial analysis can give you. So in the nonprofit space, but also in any business space, we work in the real world. We have locations for our business. We have people we work with, and those people live in specific places. And the real world often demonstrates what's called spatial dependence. Spatial dependence is a term of art in geospatial analysis, but really what it means is that things that are nearby are more related than things that are not nearby. This is encapsulated in this famous quote by Waldo Tobler, a famous geographer. Everything is related to everything else, but near things are more related than distant things. If you go to a talk about geospatial analysis and they don't have this quote in it, it might not actually be a geospatial analysis talk. This is probably the most widely quoted, geographic insight. But part of the reason is because it really underpins almost everything about how we look at the real world. It's often really important to understand what is where, but also what else is nearby, what things are near and related to your data or your place of interest in a spatial manner. And you can really get a sense of this just by looking at almost any map. You can see that, things around the farmland are more likely to be farmland. Things around hills are more likely to be hills. Things around mountainous areas are more likely to be mountainous. It's not always true. There are lots of cases in which if I come and I stand next to you, I'm not going to be more related to you than I was when I was standing far away. But in aggregate, people nearby are more likely to be like their neighbors than they are likely to be like someone half a world away. There are lots of cases, even in real world data. I think of this, you can simply look at an elevation data set and think about how things change, spatially in an elevation data set where we're looking at how tall the land is. And frequently you have, long, smooth changes where things are very similar next to each other. And then sometimes you'll have cliffs or holes or very abrupt changes. So those are, you could say, exceptions that prove the rule for Waldo Tobler's insight, but they're also really important. I hike a lot. If I am about to encounter a really big elevation change, if I'm about to walk over a cliff or have to climb up one, I really want to know that ahead of time. And the same is true for a lot of our data. So the insight that things are often like things that are nearby applies both to smooth changes where you can make reasonable inferences about nearby things based on what you know, but also applies to the fact that you really need to know when that assumption is undermined. You need to know when there's a cliff coming up. And that applies to data just as well as it applies to the topography of a landscape. So why do we need data analysis to address these real world problems? Well, the real world is really messy. It's just filled with stuff. It's filled with people and things. It's filled with buildings. It's filled with events, point in time things that happen that you keep track of, but you need to know when they happen, but also where. It's filled with movement and change. If you look at a city, very few things stand still in a city. And this can be kind of an overwhelming set of data to work with. It can be an overwhelming way to understand the world. And that's why we tend to apply abstractions to it. We abstract all of this mess into these simple forms that we can work with in data analysis. And these are some of the sort of fundamental building blocks of most data analysis approaches. These include points, a infinitely small place where something happened, a latitude, longitude location, or an event. They include lines that represent things like roads or transit. They include polygons, which might represent administrative boundaries, might represent a building footprint or other area of land. And finally, one of my favorites, we can use the concept of a grid to abstract our data even more into this kind of smooth surface of data that you can use to perform mathematical functions or other kinds of analysis. So all of this abstraction kind of allows us to take this complicated, messy world and put it into this relatively straightforward mathematical space where we can use sort of traditional data analysis approaches to deal with it and to make reasonable inferences about our data. So abstractions can support a lot of insights. This is this map on the right is a map of aggregated incidents of crime in Oakland. I always feel slightly bad about this. It's not like Oakland has a lot of crime, but it's a useful data set to look at. And by putting these things together into buckets, by bucketing these things and showing this sort of heat map of these incidents, we get a much better sense of where there might be patterns or trends. Like you can pick out the highways in this map, for example, and you can see that there's a lot of recorded incidents of crime along specific highways. You can see which areas are most affected. There's a lot more crime in this sort of downtown Oakland area than there might be in this area over here. And you can, if you're working on any kind of intervention in this area, you can start to think, where would an intervention be more effective? If I'm working on an anti-crime initiative, is that going to be more effective in an area where there's very low crime, where there's very high crime, or where you're on the edge and you want to make sure that you're sort of pushing crime back, for example? So having this abstracted view allows us to pull out these patterns and start asking questions about them, and in some cases drawing insights from them. One of the key ways to get these insights is to bring in context. And there are basically two ways that you can bring in context. And both of these, I think, are really specific to geospatial data analysis. It's much harder to do this with traditional data analysis. One thing is, we have a huge amount of contextual information at our fingertips about the things we're looking at in geospatial analysis. So if we look at this map, we can clearly pull out population areas. We can identify just from our, our knowledge that that one looks like Boston, that one looks like New York, there's Long Island. We can see these things, and we already bring a wealth of contextual information that we have at our fingertips already. We can bring that to bear on our analysis. The other piece that I really like here is that you can bring other data sets that don't have what, from a data perspective, you might think of as a real join key. So in a data context, you often think, I'm going to join these two things together, and so they have to have some specific join key, an ID, for example, that matches. You have to match a name to another name or something like that in order to bring these two data sets together. But in geospatial analysis, both data sets that have some geospatial attributes can be brought together just by putting them on a map. They can be brought together through those geospatial attributes in a way that I tend to think of as sort of a fuzzy join key. You're taking these things that don't have a strict relationship, and you're using the spatial relationship to correlate them or to bring them together in a useful way. And that's the kind of thing I'll go through in the demo I'll do later. Again, I feel like this is a really key aspect of geospatial analysis that's not available in other places. One example of this is a map I made from census data. So this is based on US Census data, and it's showing the majority racial group in each area of the United States. And again, one of the things that's really great here is that we can bring our existing knowledge to bear here, and we can start pulling out places of interest that are not only interesting visually from the data that we can see, but are interesting because we know things about these areas. So you see this, large population here that's identified on the census as American Indian. That turns out to be the Navajo Nation. It's the largest land area held by a Native American tribe in the United States. So that's a piece of contextual information we can bring into the analysis. When we look at the data, we can say, here's something that looks unusual, and we can bring in the idea that, we have ways of explaining that, or at least ways of starting to look into it and starting to draw out useful insights. So what does geospatial analysis allow us to do? The most important thing is that it's about spatial data. And as I'll get into in a little bit, more data than you think might fall into that category of spatial data. It allows us to explore data where the spatial relationships are important. That's not going to be every data set. I tend to think about things like Olympic medals, for example. Maybe the spatial relationship between one country and its neighboring country is less important than the annual athletic budget of those two countries. So spatial relationships are maybe not always going to be the most important, but for many, many kinds of analysis, the spatial relationships actually do involve do bring a really important aspect to your analysis. As I mentioned before, it allows us to combine data sets based on spatial attributes, and these are often data sets that would not otherwise be easily combinable. In this particular map, this is a map looking at the fire damage after the fire in the Lahaina area of Maui. And you can see we're bringing together point locations for businesses and other kinds of important infrastructure. And we're combining that with parcel data. We're combining that with the extent of the fire, which is shown in this sort of orangish area. These things are not necessarily things that have any, common join key, but when you put them all together on a map, you can see how they relate to each other. And most importantly, geospatial analysis allows us to, I should have said, maybe ask first spatial questions, and then in some cases answer spatial questions, or at least get more questions that we need to answer, and to find spatial patterns and insights. So you see, I've said the word spatial about 50 times on this slide, and it's because that's really the most important part, perhaps, of bringing in the spatial element here. If your data has nothing to do with geography, then go home now, and this isn't going to be useful to you. But I think you'll find that almost every data set has something to do with geography on some level, if only because geography provides this useful join key. I put this thing in the end as a kind of shout out to, to the nonprofit practitioners in the audience. In the nonprofit context, you're often spending a lot of time thinking about your theory of change. Who are we helping? How are we helping them? What is the mechanism by which we're going to affect the change that we're trying to create as an organization? Geospatial analysis allows you to bring the where into that process. It allows you to understand where you might be helping people and how the physical location can work in with your theory of change. I'm going to talk a lot about the basic toolkit. So, most geospatial analysis, it's a little bit different from what I might think of as standard data analysis. Standard data analysis, your toolkit might be, a database. It might be data queries. It might be traditional visualizations like bar charts and graphs. The toolkit is a little bit different for geospatial analysis. And I should say that this toolkit, I think, has changed a lot within the last 10 years. Maybe 10 or 15 years ago, this was really not something that most people could access. It was very difficult to create your own map with your own data. You needed expert tools. You needed a great deal of expertise. You might have needed a degree in this particular area to do it. Now, I think these tools are a lot more available to a lot more people. This started early on with the advent of things like Google Maps, but now these tools are getting better and better. Hopefully, we are contributing to this trend at Foursquare. And now you can access this kind of thing, whether or not you have specific geospatial expertise, you can get started really easily. The very basic part is that you need data with geographic attributes. Now, this can be pretty wide. We in the data world tend to think of geographic attributes as things like latitude, longitude, or specific geospatial, polygons or lines. But it could also be something like a zip code that you can turn into a geospatial attribute. It could be an address. There are lots of different ways to bring in geographic attributes into your data set. You usually need a base map. The base map is the thing underneath your data. So in this case, it's the coastline, it's the road network, it includes the names of the things around. And what the base map really does is it provides context for your data. So as I said already, context is really important in geospatial analysis. And the base map is really where you get that context when you're looking visually at your data. You can see that, this city is here, this coastline is here, and that helps you to understand why the patterns in your data show what they show. For the data itself, you usually need visualization layers. And in this particular map, we're looking at earthquakes over time in the state of California, or rather in the San Francisco Bay Area of California. All of these dots you're seeing on the map are the earthquake location. They're sized by the magnitude of the earthquake. And this visualization gives you some clear views on the data that would be hard to find otherwise. For example, these fault lines, which come out really nicely in this particular visualization, they'd be really hard to see without seeing that visually. It'd be really hard to just look at the data and understand, oh, here's a fault line where these things are all falling in the same place. Visualization ends up being a really important way of interacting with geographic data. And finally, as with most kinds of data analysis, you need tools to query and filter and transform your data. And these can range from relatively simple to very complex. And on the very complex side, you might have whole algorithms or processes or pipelines that are designed to pull out very specific kinds of insights from your data or very specific kinds of queries. On the simple side, it might be as simple as saying, show me only the earthquakes with a magnitude greater than 4, or something like that. But any geospatial toolkit is going to need some level of these tools for you to interact with your data at all. This brings me to a very brief overview of Foursquare's geospatial platform. So Foursquare provides a number of things to our customers. I would say that the main things we provide are geospatial data and then geospatial tools and software. And this sort of comprises our platform, our geospatial platform that is our main product offering. So on the data side, we have these two core data sets. One focused on movement, so how people move across the world and where people go, what things people visit. And then on the other side, the related data set is a data set of places where we have over 100 million very well curated, constantly updated data points about businesses, monuments, transit stops, any kind of point of interest that you might want to see on a map or might want to use in your data analysis. We have detailed information about these POIs, as they're known, the points of interest, that we constantly update and can bring into data analysis. And then we have a set of tools and software that we use to work with this data. The tool that I'm going to focus on in this particular talk is called Foursquare Studio. So Foursquare Studio is basically an online data analysis tool. It allows you to manage your maps and data sets by bringing them into our cloud. It provides a certain amount of free data through our data catalog that you can use to add on to your analysis. We have data connectors that allow you to connect to other kinds of data, for example, in your own database, and a variety of other features, including ways to share these things with your team, integrations with other tools, and even APIs and SDKs that you can use if you're a developer to interact directly either with data or with our software. This is sort of the basic view of Foursquare Studio. It gives you a way to manage a set of maps and geospatial data and to create new maps and then share them along with your team. And that's going to bring me to my demo. This may look very familiar. It's the slide we just saw, but this is the live product. This is Foursquare Studio. And what I'm going to do in the demo is I'm going to just jump right into it and start making a new map that's going to focus on this idea of a food bank in Atlanta. So this is full disclosure, this is a fictional use case, but I think it demonstrates the kind of question a nonprofit organization might ask and the kind of analysis they might do to answer that question. So in this case, what we're looking at is the question of we're a food bank in the Atlanta area, and we want to find a new place to add a food distribution point to address food insecurity in the Atlanta area. And so what we really want to understand is, where is there the most need? Where are there the most issues with food access right now? Where is there food insecurity? And then that's going to give us some pointers about where we could add our own interventions. So the first thing I'm going to do is I'm going to bring in some data for this map. We usually start with a blank map. This map has all the base map elements I referred to before, but it's otherwise very blank. And usually, just visually, you can see behind this this window, the map is very muted, because we're less interested in the base map and more interested in the data that we're going to show on it. So to bring in some data, I'm going to pull in this CSV file of food retail locations in Atlanta. This is pulled from Foursquare's Places data set. I drop it in. It's already ready to add to the map. I click Add the Data. And now right away, I can see this data on a map of Atlanta. It's focused on the area where the data exists. And if we look at some of the data here, we have point data, each of which is a food retail location. This, for example, is a Publix, and you can see it's got our category labeling, which is part of Foursquare's category vocabulary, which we use to identify and categorize different points of interest. It has our chain information, so this is part of the Publix chain, and we can see where every point is. And so there's going to be different kinds of chains on this map, but also some things that are not part of a chain, like Jerry's Grocery. So already just being able to drop data on a map and see the distribution gives us a pretty good sense of where there are more and fewer food distribution outlets, where there are more and fewer retail locations. And that just by itself is already pretty helpful. I'm going to do some quick hygiene here. I always want to name my maps, so I'll call this Atlanta food distribution. And by default, we call this this layer points, but I'm going to call it food retail because that's actually what it's showing here. Now, I mentioned that what I'm really interested in here is food access. So just knowing the point location of these different food retail outlets, that's not going to give us quite as much information as we want. What we really want to know is what's the service area of each of these food retail outlets. There are different ways of doing that service area, of understanding that service area. I'm going to use a fairly simplistic version in this analysis, which is just going to look at what are the neighborhoods that we can reach within a 1 mile radius. And so to do that, I'm going to turn to what I mentioned before, tools to transform your data. And I'm going to add a new column. This gets a little technical, but I think it's still fairly understandable. I'm just going to add a 1 mile radius column. We'll call it 1 mile radius. I'll use a function that we have built into Studio called buffer. And this will take the location of every retail point of interest. And I'm going to say draw a circle that's a 1 mile diameter around this location. You can see as soon as I've got this expression here, we get a little preview of what it's going to create. If you're familiar with GeoJSON, it's creating a GeoJSON polygon that's going to surround every point. I can hit create. It doesn't show on the map automatically, but if I go back into layers and I add a new layer, call this 1 mile radius, and I'm going to select the polygon type. There's only one polygon field, so right away it's going to show that on the map. And it gives us a default color for the stroke. I'll talk a little bit more about color later, but for now I think orange is fine. And now I have this 1 mile radius. I don't really need to see my points anymore, so I can put them, I can hide them. If I wanted them on top, I can reorder my layers so that different things are on top of each other. But in this case, I don't think I really need to see the points anymore. So once again, this is already giving us a certain amount of useful information. I can see gaps in these different areas where there's no food retail outlet within a mile. And so that might already be giving me some information about places that I might be interested in. There are gaps over here where nothing's happening. And if you live here and you don't have a car, for example, you might have a lot of trouble with food access. However, this is really pretty lightweight if I don't have any sense of population. So what I'm really concerned about is not just where is there no food retail, but where is there no food retail and there's population that's being unserved. So to bring in the population element, I'm going to bring in a new data layer. And in this case, I'm just going to pull it from the existing data catalog. The data catalog has a variety of different data sets that we've prepared for use in Foursquare Studio, including a bunch of census data sets. And I want not only population, but I'm really interested as this nonprofit organization looking at food insecurity, I'm interested in low income populations. So I'm going to take this census data set that has an income dimension as well as a pure population dimension. And this is going to load on the map. This is using what's called our hex tile data. Hex tile data takes existing data sets, it bins it in that hex tile grid that I alluded to earlier. So we have all this data sort of grouped by hexagon, and it provides this data set both at the sort of macro and micro levels. So I'm going to put this on top so we keep track of where we are here. Oops, that was the wrong one. Let's put our 1 mile radius on top, and let's color it differently so it's a little bit, so it stands out a little bit easier. Fill color, we can use purple just to make it pretty. We'll use the same kind of purple here. So just to give you a sense, this census data set, it has detailed information about the Atlanta area, but as we zoom out, we can get a broad view of census data for the entire United States. So this is like one way of looking at data both at the micro and the macro levels. And we can use that data, sort of broadly to investigate questions about population, questions where population is going to be a useful dimension. So what I'm going to do, I want to find a way to look at specifically the Atlanta population data. And I don't need all of the data in this population data set. I only need a limited amount. So what I'm going to do is basically just draw a box around the things that I care about. This is very roughly a box around the Atlanta area. I could use things like county boundaries if that mattered to my analysis. But in this case, I think just having a basic box around the Atlanta area is going to be sufficient. I can adjust it the way I want. And then I'm going to extract that data, which makes it a little bit easier to work with in my analysis. We're basically narrowing down on the data I really care about. This data has information for all the income categories, but I don't really care about all of them. So I'm really just going to take the total household information. That's what we're looking at right now. And the households with income below 20,000. So households in the low income bucket of the census. And I'm going to make a new data set out of that, which is going to be called an extract of the income data set. I could have renamed it, but that's sufficient for now. It'll load that data set, and once I have it, I don't really need my my full hextile data set anymore. That's going to be a little bit distracting, so I'm just going to remove it from my map, and I'm going to remove my my geometry that I used to select it. So now I have this population data set, and I have this. I can go back to my layers, and I can take the visualization layer for the 1 mile radius, and I can put that over on top. And this is already giving me a better sense of how these things relate. So I can see that there are places where there's no food retail, but there's also no population, and that's not going to be a place I care about a lot. There's going to be places where there is a high population and there's no food retail within 1 mile radius. Those might be places I care about more. So this visual overlay already gives us a good sense of where we might want to look in our analysis. But generally speaking, when I'm doing data analysis, I don't just want to see those data sets together. I actually want to join them. I want to get them into one data set where I can do things like filter one data set by the other, or create new columns based on calculations that cross both data sets. So to do that, I'm going to use another geospatial tool called the spatial join to join these things together. And if you think about it, there are two different ways I could do this. If I start with the food retail locations, I could join in population, and that would give me a sense for every food retail location. It would tell me how much population you serve at this location. What I really want to do, though, in this particular analysis is the opposite. I want to see for every population cell, how many food retail locations are nearby. And so I'm going to start with my my population data set. I'm going to select a spatial join. I'm going to choose the data set I want to join it to, which is this food data set. It already sees, well, you've got this geo column for 1 mile radius, and that's probably what you want to join on. I'm choosing intersects, so basically every place where this 1 mile radius circle intersects my hexagon-shaped cell, that's going to join the data together. And then I want to figure out, really what I want to know is how many food retail locations are nearby. And so what I'm going to do is I'm just going to count the name. So this is the aggregation rule I'm using. For every cell, I'm going to count the number of food retail locations that serve that cell. I'll run that join. It comes back pretty quickly. You don't have to worry about this column unless you're really interested in the hexagon cells, which I personally am, but you may not be. You can see that my join data set now has the census data, the sum of total households, and also has the count. So the count of retail locations that are nearby. And so now I have one data set that I can work with. I'm gonna hit confirm. And that'll throw a new data set on my map called the spatial join data set. I'm going to hide my other data sets, again, to sort of simplify things. So now I have this spatial join data set. By default, it looks exactly like what I had before because it's showing you the sum of total households. But if I pick the count of name, now I have a view where it shows a color based on the number of retail locations nearby. So without getting deeply into color, color is often something that visualization people or mapping people care deeply about. Other people think, maybe it's just for presentation, but it can actually be really important for analysis. So you can see here that the default way that we've colored this data set, it really only gives you two color classes. It gives you this yellow class and this orange class. We might want to see more variation. We might want to see finer grain detail. And to do that, we can pick from a variety of different types of color scales. One that I really like is called Jenks Natural Breaks. And this gives you a much finer grain view of how things change by selecting where the colors shift in your data. And this can give you a much nicer view of where you've got a lot of food retail versus a little bit of food retail, rather than just giving you some versus none. So that gives us a nice picture of where food retail is. What we're really interested in, though, in this particular analysis is where food retail isn't. So we're going to start by filtering down. And we're going to filter on our spatial join. We're going to pick this count of name. And we're just going to say, show me everywhere where the count of name is 0. And that updates our map and gives us this useful filter that says, here are all the places where there's no food retail within a mile. Again, the color isn't doing us many favors at the moment. So what I'm going to do is I'm going to recolor this, and not only by total households, but by households with low income. So the number of low income households that are in the areas. And so now what I'm seeing is a map of low income households that are more than a mile away from a food retail location, and I'm seeing them by their density. So this is really getting a lot closer to what I want to know in my use case. I want to know where are there low-income households that are not well served by the current food retail locations. And you can already see that there's a few here that are standing out. And if I want to highlight those a little bit more, I can see them visually, but I can also add a filter. So in this case, I'll add a filter. It's going to be on the sum of low-income households. And I can start playing with this filter just to filter things down. And you can see that very quickly, we get highlighted areas that we can use as sort of key points of interest for our analysis. There's one area right here that I think is very interesting. There's a few other locations out here where we can see there's sum of income. There are 54 households here, far away from food distribution points. But really, I think we can clearly see this area as being a particularly dense area for low-income households that is not served by food retail locations. And because this is relatively large, we can see that those locations must be relatively far away, because all of these are at least a mile away from a food retail location. So now we're getting really close to something that might actually answer our question. Usually my next step here is to do something like add an annotation. So I might want to add something to the map to say, hey, this is something really important. And we can add a point annotation, or we can add a circle. In this case, I want to add a circle that says, look at this. If I zoom in, I can see that this is the Forest Ridge area. Again, I'm getting context from my base map. So I will call this Forest Ridge. And now I've got something that is really a lot more useful. It's actually starting to look like the results of analysis instead of an in-progress analysis. One thing I often do at this point when I'm looking at a geospatial analysis I've been spending all this time with this kind of lightweight, very dark and muted base map because I didn't need as much context. I really wanted to see my data. Now I've got an area of interest. I might want to see more context. So I can switch over here. I can see a different base map. The streets base map is kind of the Google Map style base map that you might be familiar with. That's going to give me a lot more context. I can see, and one thing I often do here is drop down the opacity of my data, again, to give me a better view of the things underneath. I can see that there's an elementary school here. That might be somewhere where I could consider a food distribution point. I can see that if I zoom in, I can see there are a lot of what look like residential neighborhoods. So that's sort of affirming my initial impression that what we're looking at is a residential area with relatively low income households. And this is going to give me kind of the information I need to take whatever the next step is going to be. The next step rarely is going to be, well, let's, I've made the decision, let's go here. Really what I have now are more questions. I've got an area of interest, and I can use that as a jumping off point for doing the kind of work that I would say nonprofits usually do, of actually going out into the neighborhood, talking to people, understanding the needs, and then deciding whether this is a good place for an intervention for a new program location. So hopefully this has given you a relatively good sense of one use case that you might use in a kind of nonprofit context to understand data that has some spatial component. The spatial component here, was about location. I was asking a spatial question and getting a spatial answer. Sometimes the question you might ask might not be strictly spatial, but you can use these spatial joins to help to answer it. So I might, I can imagine, for example, that I would then join this data with data about school systems and understand, are the areas here that I've identified as having food insecurity, does it have an effect on the grades of the students, for example? Now I no longer have a spatial question, but I've used spatial data to help to answer my core question of interest. So I hope that's been helpful, and I hope that's given you a clear sense of what it might mean to do spatial analysis. At this point, I'll wrap it up and hand it back to Maya. And if you have any questions, please add them in GoToWebinar, and I'd be happy to answer them.
Thank you so much, Nick. That was incredibly insightful, really cool to watch. So as Nick mentioned, we have some time for Q&A. So I'm just going to take a look real quick and see what we got from the audience. It looks like the first question is, what if I don't have any geographic information in my data?
That's a great question because, we all have data sets, and not all of our data sets have nice, clean latitude and longitude available. So one question is it true that you don't have any geographic data any geographic information in your data? So for example, if you have an address or a zip code, as I mentioned before, even a phone number might give you a geographic jumping off point. A phone number can be attached to an area code. An area code will tell you something about where this person might be located. So, the first question is there a geographic component available in your data that you just aren't seeing? The second question is, can you join with something that might give you a geographic component? So, you might have a database of locations. You might not necessarily have, you might have data about each location, but you might not have the location of that. You might have the geographic information about that location. Can you join another database or enrich your database, your data set with more geographic information? And finally, if your data set has no geographic information at all, like if there's no sense of geography, this might not be the right approach for you. This is really an approach that's keyed to data sets where the spatial question is important. And, I think that is broader than many people might assume, but it's not every data set. So, I think that's the key question you need to ask is place important to my question, and is place important to the data that I have available?
Thank you. Yeah, and I guess in a similar vein, someone asked, what is the geographic coverage of the Foursquare data sets?
So it depends on the data set. We have different data sets in, so the places data set, for example, is, it's worldwide. So it covers the entire world. I think the total, I don't want to say the wrong thing. I'm pretty sure that the 100 million number that I mentioned was US specific, but we have at least, I believe, 200 million worldwide points of interest. There are countries that we don't cover. I think that there, I'd be surprised if we had a lot of data in North Korea, but that data set and some of our movement data sets do tend to be global. The data that we have available in Foursquare Studio, it depends. We have global data sets in there, and we have some US national data sets in there. So a lot of the census data sets, for example, are only going to cover the United States, but they cover the United States entirely and in great detail.
Thanks. Yeah, and as a follow-up to that question, there's also a question around, are there variations in the quality or completeness of your data across different geographic regions?
I mean, I think that's going to be true. I could say unequivocally yes, because every data set is going to have some variation. As a side note, one of the things that geospatial analysis is really, really good at is showing you these kind of issues in your data. If you have a data set and you look at it on a map, you will quickly find places where the locations look wrong, or you've got a large number of data points in one county and nothing in the county next door, and that can point up issues with collection. I would say that Foursquare works really hard to have a high quality bar across all of its data sets. There are many location data sets available in the marketplace, and they have different levels of quality and different numbers of attributes. And I think I can safely say that Foursquare offers one of the best location data sets available, because we spend so much time on raising the quality bar for those location attributes. That said, you're definitely going to have different collection, especially when you start looking worldwide, and you have differences between countries. People are going to categorize things differently. Different countries will have different ways of collecting that data. I've definitely looked at maps, even of Foursquare data, where you can clearly see country boundaries because the data coming from France is quite different from the data coming from Belgium, even though they're right next to each other. So there will definitely be some variation, but by and large, I think Foursquare works really hard to have a high level of quality across all of the geographies we cover.
Amazing. Thank you. All right, I think we have time for one more question. So another person asked, what are some other kinds of geospatial analysis that might be relevant to nonprofit organizations?
It's a good question. So what I've done here is something that you might call suitability analysis. There's a range of different things called suitability analysis, but generally speaking, suitability analysis is a way of finding a location that meets your desired criteria. As I mentioned in that analysis, another way of doing this is to use geospatial analysis as a way of getting to other questions about educational attainment, questions about income. You can use that by joining things like census data to other data sets. So you can look at census data and then look at school achievement data, and you can make inferences and analyses based on the join of those two, even if you aren't necessarily looking at it on a map or having a map as your final output, for example. So that's another case, is the idea of being able to use this as a join key. And I think that having that contextual awareness is very useful. I think that there's a few other places where geography can be useful for nonprofits. I think anytime when you are tracking some kind of data that has a geospatial element, so if you're tracking incidents of police violence, for example, I'm pulling something out of the air, but if you're tracking that, being able to put those things on a map will then allow you to understand what are the trends in the problem that you might be addressing as an organization. I didn't have a temporal element in the analysis that I did, but often one of the things you really want to know is, are things getting better or worse over time? Where are the geographic patterns changing from month to month? And that can be a really useful thing to understand. So I think the other big place that you might want to look as a nonprofit would be, how do you investigate the problems you're trying to solve and their geospatial patterns? And sometimes you might not strictly have a question, it might just be exploratory. And your questions come from that exploration. So you see that a lot of, incidents of the problem that you're trying to address happen in one area of the city, Now you ask why. And now you start to look at other causal factors or other ways that you could intervene.
Absolutely, that's so fascinating. I think we can maybe squeeze in one last one before we wrap up. That's okay. The question is, what is the relationship of Foursquare Studio to Kepler GL, and are there differences?
Yeah, great question. So Kepler GL is an open source geospatial analysis product. And Foursquare Studio uses Kepler GL. So we were started back even before we were Foursquare Studio. We were a startup called Unfolded. One of the premises of Unfolded was we're going to use Kepler GL, but we're going to put kind of data infrastructure behind it that Kepler itself doesn't have. So Kepler GL lives just in your browser. It doesn't have a backend. It doesn't have any place to store data. It doesn't have any way to connect directly to a database. These are all things that we saw as potential opportunities. And so Studio uses Kepler GL as part of our analytical interface, but we put a whole bunch of services behind it that allow you to do more with Kepler GL than you would be able to do in the open source product. As a side note, as you may or may not know, Shan He, who's one of the founders of Kepler GL and still maintains that project, she works at Foursquare. She works on Foursquare Studio. So really, it's been her mission to bring all the pieces that Foursquare Studio brings. Bring all these things that people who were users of Kepler GL wanted, but that you couldn't really provide in an open source product. Things we really had to offer as a service. And I think that we've done a really thorough job there of offering a lot of pieces that Kepler GL can't really provide because it doesn't have any kind of backend. It doesn't have any place to store your data. It certainly doesn't have any built-in way to share your data with your colleagues or collaborate together on a map, for example.
Wonderful.
So I tend to think of us as Kepler plus plus, Kepler GL on steroids, because we offer a lot of things on top of the basic Kepler that are hard to get to if you're working on your own.
Amazing. We love a plus plus. Well, thank you so much, Nick, for your time, and thank you to the audience for joining today. We really appreciate it. If you have any questions for us or want to get in touch, you can contact us at location.foursquare.com. We'll definitely follow up with a recording from today's session, and we look forward to seeing you at our next webinar. Thanks so much.
Thank you.